Question number 37. A cell E of electromotive force 2 volt and internal resistance negligible is connected to a uniform resistance wire of length 10 ohm and length 1 meter. Resistance 10 ohm, length 1 meter. Okay, 1 meter and 10 ohm. That means 1 by 10 will be your what you call length per resistance, or maybe if I, yeah, so I have something like this, or maybe I can say 10 ohm in 1 meter. Okay, fine. Z is a connection that may be made at any point along the resistance wire. A galvanometer is connected between Z and a point Q. Okay, a new source of EMF approximately 8 millivolt is connected between points P and Q. So you are connecting an EMF here. So what is this actually? You are finding out the EMF of the cell by using the formula E1 by L1 is equal to E2 divided by L2. This is what is the formula you are going to use, and going to this. I think you would have done this in your lab also. Okay, so where E1 is nothing but 8 millivolt, and knowing the what you call the balancing length, that's what you're going to do. Then a new source of EMF is connected. The EMF of the new source determined by changing the position of Z until the reading on the galvanometer is 0. Okay, what change to circuit will allow a more precise value for the EMF? Okay, now look at this here. E1 will be equal to E2 L1 divided by L2. Which is L1? This will be your L1, and L2 is nothing but the whole length. Okay, 1 meter. Now what is that you need to add? Now if I want to get a precise value of it, okay, larger the values of L1 and L2, L1 will definitely be larger, smaller as compared to L2. Okay, if I want to get a precise value, what do you mean precise value? See, for example, I am getting a value equal to something like, let us say 2 volt. The next value I am getting 2.1 volt and so on. I don't want in terms of 1 decimal point. I want in terms of 2.15, 2.17, 2.18, 2.19 and so on. So in that case, what should happen? This value of L1, the variable length that I vary here, should also go in terms of millimeters. Okay, but if I vary it in terms of, okay, only in terms of centimeters, then I will not get a proper value here. I want this value to be lowered. It should be more precise. Now, if I want to go this in a more precise way, then what you should do? Okay, the current passing through it should vary slowly, right? When will the current vary slowly? That's a question here. So add a resistor of resistance 0.1 ohm in series with cell E. Add, where is cell E here? The cell E. 0.1 ohm. 0.1 ohm is very lesser. Okay. Then add a resistor of 1000 ohm. See, 1000 ohm in series is a better one. When you add more resistance over here, the current passing through the wire will also reduce as a result of it. Okay, so you can easily vary this one, and the fluctuations will be much more reduced. You can use a microammeter, and for every microammeter you can find out what is the distance moved, right? So this could be a better option for me. B could be the right one. You can ask me why not 10. See, comparison of 1000 ohms with 10 ohms. 10 ohms is much lesser, so you will not get much of variation here. Okay, this definitely is least variation. 800 is comparable with this, but still 1000 if it is available, why should I go for 800? I'll always go for 1000. So this is also incorrect. So this is the right option.